Hello, good morning, good afternoon, everyone. Thank you all for attending this second session of the data quality workshop. My name is Upendo Masam. I'll be chairing this session for today. So maybe we can have a small recap from yesterday. So yesterday we had a chance to go through the efficient of data capturing, whereby Mr. Mario was able to take us through the setting up of the red cup. And Althmon was able to take us through on the different ways one can set up a project within a red cup. Furthermore, we also had people were able to share some of the challenges that they do experience with the data quality, whereby we are able to hear some of the challenges include the issue of missingness, but also the data export issues, whereby people did say about the format, different format that sites share for the import, from the export. But also we also had from the Nigeria team the issue of doing multiple training due to the people going off the project, and also the challenges with the data importation. So that was the big small summary from the day one. For the day two, we'll be going through the data quality and training, whereby we'll have a first talk from Mr. Mario, who will take us through the efficient data sharing in cloud services. And he will take us through how to access and using the trusted research environment. But we also have a second session on how to use ARA for data quality checks, whereby we also have exercise on how to run scripts on the trusted research environment. So without wasting more time, I welcome the first presenter, that is Mr. Mario, to take us through his presentation. Thank you.
Thank you very much. Thank you very much, Upendo. Let me just share my screen. I do hope that you guys can still hear me, or you can hear me well. Upendo?
Yes, we can hear and we can see your screen. Thank you.
Thank you. Let me just have a quick look at who's online, because a lot of what I'm going to be talking about have been seen by many of the the Sparkle members before. Okay, Aisha, I do not recognize. Okay, so I'm just going to mention the names I do not necessarily recognize. So it's Aisha Kulia and Maman, and then Derek Ashiampong Ajay. I hope I'm not butchering your surname, Enoch Essien. And then, yeah, so the rest of the people, so I'll try to be very brief. So one of the important things for collaboration, I suppose, is data sharing, and data sharing on a platform that is secure, easily accessible. And that is what SADC has provided via Nextcloud. You can see the URL or the address there. So basically it's hosted at UCT, but it's a web interface that allows people to just dump information. It's just upload information. So currently we do have loads of data. I do apologize for the network where I'm currently at. So things are taking a bit longer to load. So each site currently has a directory into which they can upload the information. And in that directory, if we go to Sickle in Africa data, in that directory, sites have the ability to create folders if they, for example, want to add audio, or for malaria, the MCP study, malaria chemoprophylaxis study. They can create a MCP folder, and under there they can create an audio folder, and under there they can upload their files. So the access to this is password controlled. So it's just a simple case of people uploading data. So I'm just going to quickly look at Tanzania's data. These folders were created for registry data. That's data that's been collected over the last almost decade. And in there, you will get raw data that's been cleaned by SADC. So I think the take home from, so there's raw data, there's also clean data, harmonized data, in which data, the process is run on data to make sure that naming conventions are consistent with the the Sickle in Africa standardized data elements. So the take home from this demonstration or this clip is that we have provided a space where sites can upload their data securely, easily, and only they have access. They and SADC have access to this data. And SADC has access to this data because we're the steward of this data, and also because there's a data sharing agreement in place with SADC. So that agreement prohibits us from capitalizing on your information or using it to our advantage. We're just stewards of that data. So that legal document binds us to being a steward and taking good care of your data. So any site currently, any new site will have the data protected by in this infrastructure. So that's it for the Nextcloud infrastructure, and which allows people to upload information. I think the next step would be the trusted research environment. So let me just quickly go to that. So okay, let me stop this. I'll share part of a presentation on trusted research environment, and just a small part of that, just as a brief background to provide context for why a trusted research environment is necessary. So just allow me. Let's share. There we go. So the need for a trusted research environment, if you look at collaboration between any group of researchers or any group of people, there is the sense that whatever you provide, whatever you've created, whatever is your property, that remains your property, and that people cannot steal it or take it. But you also have a need as an individual or as an individual group to want to collaborate with individuals for maximum profitability, for maximum impact. You want to engage with other people, but you still want to protect your information. So in the context of research and clinical data research and disease research, you create data. You've gone into the field. You've collected clinical data. That data for those 100 or 1,000 or 10,000 patients that you've collected is very valuable. But you don't want people to necessarily steal it. You trust the people that you work with, ideally, but you also want to make sure that your stuff is protected, your information is protected. But you allow yourself to collaborate with other people, site distant from you, who's collected 15,000 patient samples, so that you're able to pool all of your data, 10,000 samples plus 15,000 samples, and you'll be able to get more power from your analyses. And you'll be able to come up with more real life conclusions, making sure that the impact that you have of the research that you've done, that the impact is more impactful. So a trusted research environment is a way in which we're trying to provide an infrastructure where researchers can share their data, but still maintain and be the owners of that data. So your collaborator cannot walk off with your data. You can do combined analyses, but that collaborator can't leave with your 10,000 samples and now claim it as his own. So that's the background for what a trusted research environment is. So hopefully you can see the next slide. So if you can just focus on the text in red. So the idea of providing a trusted research environment is safety. So you want to make sure that data is safe. So only data that's de-identified will be shared. So no identifiable information is shared with anybody. So nobody can trace a specific disease, a specific variation or snip back to a specific patient to target that patient for whatever purpose. So all data is identified once it's shared. In a safe setting, once again, the patients or the clients or the information that you're providing is protected. Safe projects is any kind of access, if somebody wants to use your data, wherever you are, there is a process by which your collaborator should ask for access. And what kind of access? Will they only be able to, do they only want a subset of your data? For example, blood pressure, gender, genotype, phenotype. Then they need to require that to an access review community, and that group of people then decides what information is being shared. So then you can decide who you want to work with. If you do not want to work with a specific researcher based on whatever prejudice or whatever decision you've made, you can decide, no, I do not want to work with this researcher, and based on that, I will not share my information with this researcher. So you only work with approved researchers, and that approval comes from you as the owner of that information. So safe output. So wherever you allow data to be exported in this environment, you decide what that data is. It may only be summary data, for example. I think by default, people can allow summary data to be exported, but anything more than that also needs to go through a review process. So I think that is taken from that. So the next thing I would like to point out, so in this trusted research environment, we have provided through our collaborators an environment in which you can analyze your data. And Martha's going to talk about this some more after me. There is a need for data analysis and data analysis tools. Everybody has a favorite tool that they want to use. Excel is one of them. The challenge with Excel is that it's not necessarily sustainable, or because once you have your Excel sheet, somebody needs to manually, look at the Excel sheet, process it, take from there what they need. R and R Studio allows you to create a set of instructions that run over and over consistently, the same set of instructions. You can share that set of instructions via script with anybody, and they can use your analysis steps and processes. And if you want to validate, if somebody wants to validate your results, they can run exactly the same script on exactly the same data to validate that. So RStudio and R is a very good tool when it comes to collaboration. If you want to collaborate with people, researchers across the world, it's good to have a tool that allows that sustainability and that compatibility across different countries, different research sets. So with that, I'm going to stop this, and then I'm going to quickly just go to the trusted research environment that we have, that we are implementing currently, but also, so that's the one that we start with. So our collaborators at ILIFU. So ILIFU is an initiative started by and supported by the South African government, with support and input from the academic institutions in South Africa. That's UCT, UWC, University of Cape Town. I think Wits, the Witwatersrand University is also part of that. So this is the platform that they use for data analysis. So if you want to access the trusted research environment that SADC is currently running to support the consortium, this is where you apply. I'm going to paste this in the chat box quickly. So this is the location of that application form. So what it will ask you is your email, of course. This bit is for those people who are, programming savvy, used to using the computer, the command line. You provide an SSH key that it's just, the SSH key is just a key or authentication method that allows your computer that you consistently use to be recognized by the servers that ILIFU runs. So it's just basically it's your key to get into their servers. It will ask for your name, your surname and your registered institution, country of origin, and what is your position in the group that you're currently at. And then which of these ILIFU supported projects are you working on? As you can see, there are several. There's computational biology. There's a bunch of them with that does astronomy research. So there's something like antennae galaxies. Path Magellan is also, I think, astronomy element. So a lot of these are astronomy. Meerkat, most of you may recognize that. So you scroll all the way down to ILIFU Bio, which is bioinformatics, and then you select Sickle in Africa. So if you want an account, you go through all of those, the information, and then you select the Sickle in Africa as an option. And yeah, so the next bit is, so accessing that, once you have an account, you will be able to log into this interface. Let me just get my password. Okay, just give me a sec. And once you log in, once you log in, you are provided with an interface. Okay, let's just do this again. I think, okay, let's refresh. Okay, so why is it not? Just bear with me quickly. I think it has to do with my network. So what you'll be faced with is if it eventually, there we go, is an interface in which you can, it gives you a set of options. So one of the things you'll generally be using will be Jupyter. Jupyter is the Jupyter notebook. It's what you'll be able to, you can run your scripts in. So if you go there, so that's where you'll be running your RStudio scripts, etc. And I think I may be in the wrong place, so I do apologize. Let me just see. Okay, yeah. So what you'll be faced with once you log in to this trusted research environment provided by us, you have all of these options for tools to use, for applications to use. And one of the things that you'll be using will be, and Martha will do this now shortly. Martha, how am I doing for time? Okay, so I've got 6 minutes.
Yeah, I think you're fine. Yeah.
Okay, sure, thank you. So this is what you'll be selecting. You'll be looking at the RStudio console, and you'll see this more when Martha does a bit. Come on, what am I doing wrong here? Oh, it's still thinking. One of the things with the trusted research environment is, so once you've selected, when you do application, once you've selected that you want to go to ILIFU, Bio, and Sickle in Africa, is that you get added to this group, and in there you'll get all of this this protected data. So there's NBS data, for example. Let's see, let's go to Nigeria. Let's see what we have there. So in there, in there you'll have this bunch. Let's see what it shows us. And you have all of this information that you can then combine with yours and do analyses on. So you can see there is, let's see how many records there are. This is 100 records. These are the preliminary NBS, the pilot study. This is data for that pilot study for the NBS research project. So I think I'll stop here. So the take home from this is that there is an environment that will allow you to do analyses with collaborators in a safe space. That's one thing. And also sustainability of data analysis pipelines, if you want to call it that. So Martha will also, I think, she can correct me if I'm wrong, she will also, so basically you have a set of instructions that does a specific thing. that comes up with a specific set of analyses and results. And that is reusable. You can share that script or that set of instructions with anybody around the world, and they'll be able to do exactly the same kinds of analyses, maybe with a different data set, and be able to come up with analyses that they'll be able to then publish on or take further for further research. I think with that, the 3 minutes left remaining, I'll leave that there for and open up for quick discussions. And I think that's it from me, Martha. Thank you so much.
Thank you, Mario, for that presentation
Thanks,
on the
Upendo. Yes.
Thank you, Mario, for that presentation on the Nextcloud and the trusted research environment. So does anyone have any question to Mario before we go to the next session? You can just unmute yourself and ask, please. So sorry, Mario. So the trusted research environment is connected to the Nextcloud, right?
Sorry, I was talking to myself. So no, it's not connected to the Nextcloud. So this is the first iteration of the trusted research environment. So what we do is we then take data from Nextcloud, transfer it to Lufu, and that's where that's where the data then resides in two different places. The next phase, next stage of the trusted research environment or implementation of it will be something called Gen 3, and that in that we will strive to link the two. So whenever somebody uploads their data to Nextcloud, that directory or whatever will be attached to the trusted research environment, the new trusted research environment. So then the data is readily available, but at the moment it's not.
Okay, thank you. And then the ILIFO, does that allow people from other institution or country to have like a space like the one that you have for Sickle in Africa, or it has to have a person from South Africa to do the baseline application, then connect other countries?
I think so, yeah. So basically, it's South African based. Evans, I'll get your question now. It's South African based, so for all intents and purposes, it's just limited to South African institutes. But like in this case, for example, we have non-South African collaborators. So I think that allows us to liaise and provide, for example, some of the people on site on this meeting have accounts on Elifu. Because they are part of the Sickle in Africa initiative and the Sickle in Africa group. So it's limited to South African institutions, but through institutions, South African institutions, other countries, because they are collaborators, probably also have access to the resources there. Ilifu is, like I said, how to get institutions get TRE and Ilifu. You don't get Ilifu, even as I explained, it's just South African based, but I think maybe other countries have something similar, just like I think I don't know how successful it is still, but the research network in several countries that allowed academic institutions to be connected together with high-speed internet. I'm not sure how far that has gone in a lot of countries, but I think all countries can probably have their own Ilifu setup. But that requires financial resources for for server infrastructure, etc. So it may be a big financial layout. TRE, a trusted research environment. I think anybody can implement a trusted research environment and run that. So it's not something that's exclusive to Sickle in Africa or to SADC. Your institute can probably run a trusted research environment as well. They just need to get the proper software. Yeah, so I don't know. I hope that answers your questions, Evans.
Thank you, Maria. Do we have any other question from member? So if none, then we can go to our second presentation that will be done by Dr. Martha, who will take us through how to use ARA for data quality check. Welcome, Martha.
Thank you, Ependo. Good afternoon, good morning to everyone. Before I begin, just give a brief introduction. I will be going through a sort of semi-interactive session for these next 30 minutes or so. And I'm going to share a link in the chat. If you can open that link, and while you're busy opening it, the link will lead you to a cloud environment where we'll be able to download the script that we'll be using this afternoon. But in the meantime, I'm just going to share my screen while everyone is accessing the script. Let me just share my screen. So, yeah. Let's, I think maybe we can take a few minutes, like maybe 5 minutes or 3 to 5 minutes to just go to that link, for participants to go to that link and download the next script that we'll be going through in this session. So we'll be looking at an R script, and I would like to show you some of the steps that we go through at the coordination center when we receive data and how we analyze it in R. The link that I've provided is to a cloud environment called Posit R Studio. The reason for that is that because of privacy and security concerns, we won't be using the trusted research environment directly today. We'll be using this alternative. So are there any questions?
Hi, Martha. So the link requires us to log in.
Oh, yes, that's the thing, yes. So for the next few minutes, you can either sign up for the POSIT environment, or if you have a POSIT environment, you can sign in. So I'm gonna give you guys some time to do that. So that's why I said it's a semi-interactive session today. So in order to download the script, please go ahead and either sign up, or if you've, yeah, hi, Mario.
I have found that I was able to log in with my Gmail account. So
That's
maybe people can
great.
try with the existing, with the existing email accounts without having to sign up for POSIT. If you can
That's
try
great.
that would work.
Yeah, that's really good. So if you can use your existing Gmail account to sign up for this, this way we'll be able to step through the R script together. And we can just illustrate some of the steps that we at the Data Coordinating Center go through when we analyze or start looking at data. So if, please let me know if you're having any issues logging into this POSIT. So POSIT is like a cloud, let's say cloud setup where you can run RStudio exactly the way you run RStudio on your local lab, on your local machine. So if you're familiar with RStudio, there's a RStudio software that you install, which is open source meaning that it's free. You don't have to pay for it like you do with Microsoft stuff. So you'll be able to see a similar setup of RStudio in POSIT Cloud.
For those who have been able to log in, kindly can you type thumb up in the chat?
So Nafisa Sani asks, which password should we use? And, so in order to log in, because you're using your personal email, Gmail account, just go ahead and use your personal Gmail details to access this cloud environment. Okay, so I've got a thumbs up from Derek. The intention of this session is not to rush through things, but just to familiarize you with the kinds of tools that we use, or we can be able to use to analyze our data. I know Mario mentioned reproducibility and sustainability and collaboration, and using Posit Cloud is one way to encourage collaboration. I'm just gonna give people a few more minutes to give me a thumbs up where once they are able to access Posit Cloud. Pendo says, yeah, they're able to access. Oh, please resend the link. I will do so. Let me just do so right now. I'm just gonna stop sharing screen. Oh yeah, thank you, Mario. Thank you. Thank you, Wilson. Okay, so for those who are able to log, can you see my screen at the moment? I'm just gonna stop sharing and reshare my screen to be able to get into Posit. In a moment. So once you've logged in, this is the interface you're facing, or you'll come across. It's very similar to an RStudio setup on your local machine. And what we need to access is these data quality. If we look down on the right, towards the bottom of the screen on the right, we have this data quality workshop.r script that we're going to walk through today. If we click on it, this is what we are presented with. So the intention today is just go through all of these steps and see what we at the Data Coordination Center try and do to get to understand the data that is shared with shared with us by the different sites. Yeah, Valentina is looking at the chat. Okay, so yeah, great. I'm gonna stop sharing screen and share the my screen again regarding my presentation slides. Let me just do that quickly.
Martha, just checking, are you still online?
I think Martha got disconnected. So she's.
Noted, Osman. So while waiting for me to come back, are people able to access that and actually start browsing around, clicking on stuff? Is that would be a good thing
I do
to?
sorry, hi, I do apologize for that. Sorry, Mario, you were saying something? I think I got kicked out.
No, I was just filling the air until you came back. Please go ahead.
Okay, great. So now I'm going to share my screen and we're going to do a step through the R code that I hope everyone has access to. So looking at my screen, the interface that we see at the moment now is on the cloud, meaning it's somewhere on the internet. And then if I look down towards the bottom on the right, we have what information or resources we have. So if we have look at the data file, we see that we have some data somewhere stored in the data file, and then we're gonna just click on the R script, and we're gonna step through the R script and just understand what we're just look at some of the steps that we go through as we are analyzing data here at the data coordinating center. So the purpose of this script, as I mentioned, is to manipulate the data that we get, but we're using R in this instance because R is universally accepted by most of the statisticians. And if you're not a statistician, a lot of people who are machine learning experts like to use Python, but we're not going to be using Python in this instance. But we do sometimes use Python at at DCC. And then the next purpose of the script is just to be able to identify how we look at data quality issues using R. So at the end of this step through, although we may not get through everything, at the end of this step through, we just expect you to be able to open the R environment, load the toolbox, if I can call it that, which is the packages that we use in R to do data quality checks. And then we'll be able to look at some form of data wrangling, where we look at summarizing data with R and then being able to fix our data quality issues using R. So the script, as you can see in front of you, allows you to navigate R and then identify data quality issues. And then we'll be able to, once we have our data set loaded, we'll be able to say this data set for later purposes for using data in another setting. So sometimes R is quite a very useful tool because it has many toolboxes, if I can call them that. These are libraries, I like to say toolbox because people can relate to toolbox more than they can relate to when someone says a library. So you have a toolbox, lots of toolboxes that you can use, and you can call upon these toolboxes by saying, load this library, or load this toolbox that will allow me to do something with maybe the date, or with plotting, or with displaying stuff, or with reading packages from Excel files. In our case, we have a data file folder. I'm just going to erase all of this. If you're able to, you can step through the code with me, and then we'll be able to just run some of these commands as we go along. So I want to load data, and then I know where the data is located, and then the name of the data file. And I want to ensure that once I load this data, I also read the headers in this data. When I run that, there's a run button up there. Could not find the README file because I neglected to run those first few lines of the I neglected to load the first few packages in that in this environment. So load the environment or load those packages by running those lines of code. And then we'll be able to see I'm just gonna sort out this error because we're doing a semi-interactive session here. It says here the error that is unable to recognize some argument header equal true. Let's try and delete that and see what happens now. So it's always important to just read what the output is telling you. So now we have a clear output, or we have something, no more errors presented. And then we check out, okay, we've loaded our data. Now we're going to see, okay, let's look at the type of the data that we've just loaded. When I started learning R, a lot of the data that we used to load into R was loaded into something called a data frame. And with the advancement of R and with the development and updates to R, they've now shifted to something called a table. So now if you look at the kind of data that we just loaded, we've loaded something called a table frame. Previously, it used to be called a data frame. And then the next step we usually focus on is looking at the data. So we check out the data, we look at what the headers are, what the types of the different column entries are. So in the next thing, we'd like to look at to view the data because it's always a good idea to view what the data that we're looking at. So if we run the next line over here, we have data. We view the data and then it gives us a separate window that allows us to see, okay, we've loaded this data, we've got some fields, we've got several interesting fields. And now we want to start analyzing these fields or start understanding what all these fields are. If we look at the header of the data, in this case, we ask it to give us the default number, a default number which is 5, tells us, okay, default number, which is 6, sorry, tells us, oh, okay, we have these kinds of rows in these kinds of entries in the data and so forth. We can also look at if we type string data, we can look at the data types, the entries in each of the columns, the number of rows, we have 4,888. We can look at the number of columns, and the dimension just tells us we have how many rows and how many columns in this data frame or in this table data structure. I think maybe I should pause here and just ask if there are any questions, comments, or maybe there's a request that I do this faster. I'm just gonna check the chat. Okay. Okay, so another great thing about R is that once you install R on your local machine, it comes with documentation pre-installed. So I recall from previously that I had used read Excel to open an Excel file. But if I didn't know what options there are or what options I can use along with this Excel command or this open command, I can type the question mark command and ask, how do I use this function? When I do that, I'm able to pull up the built-in documentation. Yes?
Martha,
Mm-hmm.
the chat box, the Zoom chat box is covering part of the
okay. Trying
screen.
to get rid of it.
Just close that. Click on the X.
Yeah, that's
And just close it.
It's
Not working.
really, not working. So I'm going to reshare
Yeah,
my
that's one of
screen. Can you see my screen now? Let me just stop resharing and reshare. All right. So one of the nice things about R is just digging into the documentation. And once you can do that by typing out this question mark and command, or sometimes they call it a magic command. It just pulls up the help. So if we look at the help that allowed us to read the Excel sheet, we can see on the right-hand side of the display of the screen here that, oh, this is what Read Excel does, and this is the options that we have that we can enter into Read Excel. You can even look up what View does. View allows us to invoke a data view, so it opens a separate window in which you can view the data as we saw previously. And of course, if we look at head, it will tell us, okay, head returns the first 6 entries in a data frame or a table, and string, of course, returns. If I can put it simply, it's, if you don't want to go through all this documentation, is that string tells us what are the types of data types that are entered into each, that are in each column. So if I run string again up there, we see that in the bottom left screen, we see that record ID is a number of type, a data type of number, and so forth. You have character entries and all that interesting data type entries. If you want to look up further documentation, especially if you don't have internet access, if you install R, it's possible to always pull up the built-in documentation for this environment if you've installed it on your local machine. But to look up the help, and you type you do so by looking at the help.start, and if we run this, it will again pull up this statistical data analysis and bring you all the manuals about all the various packages that you have installed in this environment for your analysis purposes. And if you want help on a specific package, you can specify the name of the package by doing help, open brackets, and looking at the and specifying the package that you're interested in looking up. So in this case over here, there's just if you want to, you can look up the help on ggplot2, and then you see, okay, oh, what does ggplot2 have that I can use? So if you're restricted with internet or you don't have internet access, it's just know that there is built-in documentation for R that will allow you to see how most of these functions work. So the next step that I would like us to look at is identifying data quality issues. When you have loaded your data set and you've done all these steps to view your data, to view what type of data is in your data frame. So now you want to check maybe, okay, now I've loaded this data. What are the column headings? Maybe are there any missing values? So that's a really important question to be asking yourself as you look at this data, like what are the missing values? Can I visualize these missing values? How do before you even start processing the missing values, I need to know what amounts of missing values are there, and then maybe also summarizing the missing values. So there's a request. Okay, I think I shouldn't click on this message thing while I'm presenting because.
Yeah, I think we will, between Wilson and myself, we will check it, and
Okay.
then we'll just draw your attention to stuff.
Okay, thank you so much. I'm just gonna reshare my screen.
Okay.
All right. So step 2 is looking at how we go about identifying data quality issues. So obviously, when you get a data file, the first thing you need to do is just open the data file and look at the data before you even start writing code to process this data. So opening it and viewing it is an important step in analyzing your data. But then now if you want to take a deeper dive into the data, you can start looking at specific things. So in this case, we're now looking at, oh, do we have column names in this data? What are they? So we can run these columns names. It's a function, a built-in function that allows us to just say, okay, given that the data I have, I can just look at the columns that I have, and then it prints out a list of the names of the columns in our data, in our table structure. But now if you want to check out if the columns, all the columns have names, there's a command that we can easily run here as well, which is, it's a command called which. You want to check which columns don't have names, or which columns have names that are empty characters. And then we can run this and it tells us, if it says integer 0, then we know that, oh, okay, all our columns have names, and we're happy. We can also start looking at entries in our columns. Like for us at the DCC, we do not really know what kinds of entries that the different sites have chosen for their, but these entries that the different sites have chosen depend on their code books or their, as Mathamon mentioned, that there's a code book for how some of these values or fields in the data frame or data sets are recorded. So we can start looking at things like unique. So if we're examining column entries, we can look at, so we saw that there was a column on consent that was given in our data set. We can start looking at, okay, so what type of consent was given in this data set or at this site? And if we look at that, we look at the unique entries in that consent entry, and we see that there was written and verbal consent that was given when participants were asked to enter, were asked to participate in this data, in this study. So the next option here we look at is, the next thing that we look at here is, has the patient consented? So if we're looking at consent, and this is just one of those risk questions that we start to ask ourselves, is what type of consent was given? And maybe has the patient consented? And we see that the entries in there are yes and no. And then we're like, okay, we're happy to work with written and verbal consent, but we also need to figure out if there were any other sorts of consent. And using the keyword unique here, we'll be able to pick up exactly which types of consents were given, and then which types of entries were given for has the patient consented. So we see that the types of entries that were given for patients as a consented is either a yes or a no, and there's no entry related to yes, to unknown or invalid or anything of that sort. So in that case, we are happy. If we look at other columns, for instance, the blood group, for instance, we look at, okay, what kinds of unique entries were given in this for this column. And we see that here, if I run this and if I look at the bottom left screen, I see that there's O, B, A, invalid, and a small letter O. So these are just some of the things that we start to pick up in the data quality issues. So we can infer from this that the small letter O and the capital letter B, O mean the same thing, and we can start to fix that in the code. And we can do so by using a function called mutate. At this stage, I don't expect everyone to know how mutate works, but we've provided the code here and a way to check out what the documentation means. So if you're unsure about anything, always do a question mark, which means help me find out what mutate does. And then we have, okay, check out what mutate does. And on the right-hand side of the screen, we see you get help on what mutate does for us. But in this case, we're going to use the mutate function to just make sure that all the entries for the blood group are consistent, so that all the entries are capital letters and so forth. So if we run this mutate function on our data frame, on our table data set, we can now check, okay, has it exactly done what it's supposed to do? And in this case, we are happy. It says, oh, okay, it has now converted a lot of the O, that was a small letter, to what we want it to be. I think I'll pause here and just maybe ask if there are any questions so far. I see there's a marker, a red dot for something. Someone has posted something in the chat, but I'm not gonna click on it. Mario, is there a question?
No, it's the question from Derek earlier, so that's why it's still flagged.
Oh, okay. All right. So the steps that we take are just a way to familiarize ourselves with the data. I'm not making, yeah,
Maybe,
yeah.
yeah, thank you, Martha, for a nice talk. I think that maybe when you present some of the functions, for instance, the mutate, I think it will be good if you go just explain what do you want to do with that one so that
Okay.
the participants at least can follow. For instance, here is that we wanted to convert where there's a small a to capital A, things like that. I think it
Yeah.
will make it easier for them to follow. Thank you.
Yeah, so I think I stepped over some of this stuff very quickly. So the mutate function, if you don't know what it's doing, always ask for help. And first, ask for help in the documentation. And this is the first step, question mark mutate. And then now, if we look at what mutate is actually doing to what it's doing to our data, which we had uploaded earlier, we stored it in a structure called we named it data. So now we're looking in our data and we're saying, okay, find me the column blood group or BL underscore GRD, which means BL blood group. And in this case, if we find that, when we find that column, we want to apply a function called to lower on that column. So in the case that the blood group has a small letter A, change it to a capital letter A. In the case that blood group has a lower entry B, change it to a capital B. In the case that it has a lower AB, change it to a capital AB. In the case that it has a lower O, change it to a capital O. And otherwise, anything else that we don't recognize as a blood group, just call it invalid. So this is what, so in this case, we're using something called a piping operator. A piping operator just means that once I apply a command, take the results of that command and push the results to the next stage of processing that I want to do. So once I've taken blood group and I've processed it, looking at only the letter A, take those results, which now have the result A, and push them to the next processing stage where I now just look at B. Take the results of processing B and now push them to the stage where I'm just now looking at AB. Take the results of processing AB and push them to the stage where I'm now just processing blood group O or small letter O. So this is what that percentage less than greater than or greater than sign percentage symbol, all those symbols are doing for us. So we've established, we've got, okay, now we've really now just converted all our results to something that we can work with that's consistent, and the consistency is now established by having capital letter O, capital letter B, capital letter A, B, and capital letter A. And the next thing that we always want to look at is missing values. Missing values can tell us a lot about whether, if we look at the display of the missing values, they can tell us a lot about whether the data is missing completely at random, or whether it's missing at random, or whether it's missing not at random. When data is missing completely at random, it means there's no relationship between the way the data is, no relationship between the observed and the value that's missing. So one of the things that we can do is sum up the missing values. We see that, okay, once we do a summation of the columns and the values that are missing, so we're looking at a function called an inbuilt function that says, tell me what the sum of the missing values are, the missing data is. That's per column now. And this is this line of code over here. We can now start to look at, okay, it tells us in record ID, we have 251 missing values. So this immediately raises a red flag, like why are there record IDs that have no information? How do we uniquely identify a record when it doesn't have an ID? So this is one of the things where we can maybe start to do follow-ups with the sites and see, okay, yeah, maybe there was some sort of data loss as the file was sent to us, and so forth. Then we can also sum up the amount of missing data in our data frame. So there's an entry error over there. I have an additional closing parentheses. Sorry about that. Just rerun this and you can see. Print. So now I have messed up my script somehow, but let's try and fix that. Okay, let's just skip this for now. I will get back to this issue here a bit later. So if you want to visualize the pattern of missingness in your data, we can install another toolbox here that's called Nina. And this toolbox allows us to say, okay, to look at the patterns of missing data, the visualize what we are dealing with at the moment. Just in the interest of time, I think I have 4 minutes. I'm just going to do this for now to fix that error that's popping up on the right. So now we want to look at visualize the pattern of missingness in our data. I believe we haven't installed this package yet, so we can try and install it right now. So I need to use this toolkit. So this toolkit, I will install it. And then I can now upload it into my environment by using library. And then now I want to start using some of the functions in this toolkit. So there's a visualization underscore missing function here where I just say, okay, this is the data that I want to visualize. If we run this, we get a visualization showing us the pattern of missingness in our data. So at the top, we have the columns and it tells us the percentages of missingness and so forth. Maybe I can pause here and ask for some questions or maybe wait for some questions.
Hi, Martha. The diagram. So these are columns and I don't know, the columns names up, right?
Yeah, the column names are up there and they tell us the percentage of what's missing in there. So it's for telephone number underscore 2, it tells us 88% of the data is missing. Telephone number 1 underscore 1 tells us that 56% of the data is missing. And so
Does it
forth.
does it do the fraction per number of records, right?
Yes, it does. It looks at the total amounts of rows and row entries in the data frame or the table and data structure. Does that answer your question?
I think we have a hand from Mario.
Yes, Mario?
Thanks, Martha. So my understanding of this is, so on the left, it's a number of observations. So where it's black, a specific observation has no information.
Yes.
So where it's gray, that specific record has information. Is there a way, there must be a way, but it may not be as simple. Is there a way to then flag the actual records that have missing values, for example? Or maybe just give a subset of the observations where that is present so that the others can be flagged and highlighted to sites.
The quick answer is yes. The long answer is we have to go
Okay,
into
got
the
it.
code and start doing that.
Yes, yes, of course, yeah. Cool, no problem. Yeah, that answered my question. Thanks.
Yeah.
Thanks, Martha.
There's also another thing that we at the Data Coordination Center start to look at when we get data is the distribution of the data that we receive. So for instance, if we receive information on height, for instance, we have a height column in this data frame or this. I keep saying data frame because I'm used to Python's data frames, which originated from R data frames, but now R is trying to shift away from data frames and into tables. So I'll keep saying data frame. So it's to look at the distribution of the data. And in this way, we can use a function called the hist function and just say, okay, I want to look at the specific column and I want to look at its distribution. And the function that allows me to do that is the hist function. And I have options, like I can specify what the visualization's name that I'm going to present is, what's going to be on the x-axis, what colors I'm going to use, and all and a lot of that fancy stuff. So if we look at the distribution of the heights in our data set, okay, we see this weird distribution. It doesn't look normally distributed, but then we start to ask ourselves, okay, is it really normally distributed? And therefore we can start running things like QNorm and looking at the QQ plots just to ensure that, okay, we're actually dealing with a normally distributed, height here. So if we look at the QQ plot for our heights, we can see, oh, okay, yeah, they sort of follow some normal distribution. If we draw a line, a straight line, okay, I should have entered that straight line to show us that we're now comparing what our data looks like in terms of the quantile percentiles to what we expect or what the standard normal distributions quantiles should be like. So any deviation from a line that a straight or a diagonal line along what my cursor is doing indicates that, okay, some of these data points we need to pay attention to. Are there any questions regarding this so far? I think I'm a bit over time, but yeah, so just to get to this point where we are, understanding the distribution of the data that we're dealing with, for instance, in this data set, we have something called the height and also something called the BMI. We know that theoretically this data follows a standard normal distribution, but if we get data and this data does not follow a normal distribution, we need to look at what's happening with that data. Are there extreme values and things like that? I think I will end over here because, as I mentioned earlier, this is not meant to cover, this session is not meant to cover the whole script. The reason we gave you a link to the script is that you can run the script by yourself and then you can see, oh, okay, this is what's happening here. So I think I'll end here and I welcome any questions.
Thank you, Martha, for that hands-on experience on using R.
Okay.
Do we have any question? I know it may have not been easy to do it, to watch the presentation and doing the analysis, but as Martha said, you have access to the platform, so you can go back and have some hand-on practice. And if you do face any challenge, you can kindly contact Martha. So do we have any comment or question from member?
Yes, maybe I can raise up a hand.
Mm.
Martha, thank you so much. I think this is kind of the stuff that really people should make sure that they put hands on it so that they'll be able to do quite a good number of work from the side. And that being the situation, then is there any possibility, for instance, if we have the data sets which you already know, for instance, malaria chemoprophylaxis or for the newborn screening, maybe when we start working on this kind of data, at least you have a script which you can share with the sites to ensure that maybe they run from time to time. And from there, I think they'll be also be able at least to practice and become more conversant with the ARA in terms of how they prepare their data, how they do the cleaning. And
Yeah, I can.
I understand that it is really challenging because if you really don't work with ARA for some times, even what you had a little will start disappearing. Thank you.
Yeah, that's a very good question, and it's something that it has been brought up as well, like having a script that we can share with the sites just to analyze, let's have the same starting point for analysis. And I think it's certainly possible for us to provide a script, an R script that will be able to analyze the NBS and the MCP data. I mean, I think that's what we at the Data Coordinating Center, I may be speaking off script, but that's what we at the Data Coordinating Center are meant to be doing. So it's certainly possible to provide a script that as a starting point for NBS and MCP. Does that answer your question?
Yes, thank you.
Great. And I will, I think I will look into this as well. So yeah.
Thank you, Martha, for this, but also the hands-on practice has a data set that everyone can work on.
Yes, there is a data set, yeah. So once you sign up for posit.cloud, you can start practicing and doing some, just running through the code and see how far you get. But please do not hesitate to email me. I'm more than happy to answer any questions.
Thank you, Martha, for that. Do we have any other question from member? So if none, then we'll go to our last session that is on the panel discussion, whereby we'll hear from Mali, Uganda, Zambia, and Zimbabwe site on the challenge with data upload, data storage, and using the trusted research environment. So do we have a representative from Mali?
Yes, Dr. Saro is here.
Okay, welcome, Dr. Sarah.
Okay, thank you. Just prepare a few slides, nothing much, just to explain our just to support my talk. Thank you so much for organizing this workshop. I think it's a great interest, and we are seeing every day new thing, like the tool you share for transferring data and everything. It's very important to see, and thank you so much. Let's see what to tell. Okay, just a few slides that we prepare for this. In Mali, we just get involved in our analyzing our registry data, and during this analysis, I think the average person who help us during this analysis are here. I think especially Wilson, he's here, and thank you so much to Wilson for helping us. And we can, I'm just going through some of those issues and as our experience, and if I forgot something, the others person of my team also can complete. And okay, this is just a little background. That's we are new CRLD. We just opened in 2015, and we apply on this Sickle and Africa consortium, and we get an hour. And the first protocol we get through, it was the registry, and it was really our big protocol. But before that, we just ran a newborn screening protocol with French team that go through 4,000 newborn screening. That it was not so heavy like with registry. And under this Sickle in Africa, everybody know that we have a newborn screening and malaria chemoprophylaxis, which just begin in Mali now. Just going through some challenging that we see during this analysis, and it was really the consistency of the data. I mean consistency. We during this analysis we get a lot of discrepancy between CRF and what was entered in the database, and some of those was just catch up, because if this the data set was really far from what is normally shown, and we go on the CRF and found that it was just a typo, or it was just some not well written, or some of those things, and we get a lot of those, and that mean really for having quality data, it's really good to have those. What everybody knows is having two person entering data and compare each other, or verify each entry to be assured that the data which is entering in the database are really the right one. That we face some of those accuracy problem also, because those two are almost the same, that the data which will be entering the database will need to be accurate. And the lesson we learn from here is really we need to check a very good checking part before entering data on the database, because most of, if they, it's not I think it is not clear, or once it's entering the database, it's difficult to really catch the error, unless it is something which is really out of range. It's very big data or small data that we can tell, this is not clinically possible, and we can catch up. But if it is possible, that people may not see this error, and this consistency and accuracy need to be well addressed when the data is captured for clinical study. And for example, we during this analysis we get a lot of issue on phenotype data. Phenotype data need to, because this is the main data with which we will go through our comparison and everything. And we cannot tell somebody is SS or if in reality he is SC or something like that. To correct that, I think Wilson is here. We have working on that many months ago to really check all the phenotype data. And the lesson we learn from there also is it's possible for the data element to be more to help to cut some of those data. For example, we saw that some of those HPLC profile, the hematologists teach us that there is some value don't go far from some value. For example, people don't have a lot of the percentage of A is 0, sometimes is A. And I think if we work hardly with hematologists, it's possible to really put some coding on this phenotype part, and it can help to really catch a lot of error. And this was not done, and what was done is we really put some of those coding and try to see all the phenotype which is in between those, and get the profile and check them. And it was really helpful, and we found a lot of entry error or interpretation error on those phenotype, which if we didn't go through, we may get some interpretation problem, and which can lead to some conclusion which is not right. And for biochemistry, what was our problem there also was really if we in between, sometime we can change analyzer, and some analyzer will give the unit may be different, and that also need to be very careful. And I think the data element from Sickle in Africa was really well written, and we have unite there. But sometimes some of those investigators was not really read it carefully, and we may end up for some biochemistry data not convert. And those also, we as Martha was telling, through through air coding, Wilson help us. We cut most of those non-converted biochemistry data, and go back and see what was wrong. And we found that it was not converted, and we converted and put those data in, and most of our data was really right. And for height and weight data, we get some issue on that also. And those issue was really some not realistic data, because some height was not really realistic. And those one, if we cannot go back to the patient, we just take out those data to do not be be having wrong data. And some in blood pressure and others data also, the physician are really used to round the data. And when they round those data also, it's not right, because those around it will end up to be almost the same data for everybody, like 12-8, 12-8, 12-8 for everybody. And that also we found not really helpful for analyzing. And we just report, and I think it's teach us to do not round those data for our coming protocol, and we implemented those method to our clinic, and to be able to use those blood pressure and oxygen saturation data for everybody, because if we round it, we end up with 80, 120 of everybody having the same value, and no difference cannot be found between those patients. That's some issue that we found. And as I tell you, our data, the Sickle in Africa data element was really quite good. And for us in Mali, it was very good because we have the data element translated in French, and people can see vacation in English and French and know what is asking for those data element. And what I said before is what can be really done for REDCap is really to put coding and everything to catch data during the capture moment. For example, putting some limit or some coding to really catch what is not right for those data. For optimization, I think we need to program to minimize error in REDCap. That is just a repetition. And if we can implement fully double entry and making a step of many checkup points, that also can be optimized, and we will end up with quality data. Or if we can sometime randomly see some of those random verification for some data, that also can help to end up with quality data. It's what we really did for our data. We really verify most of those entries and end up now with very good quality data for our registry. I think this morning Mario told about our storage part. Well, our storage is not quite right until now because we have server, and as the people can see, the server are not well stored yet, and we are working in our side to really have a very good storage for our server, and having regular backup also from the server to not lose the data. But for now, we are not really quite good on this storage yet. Sharing also with connectivity, some connectivity problem can be an issue, but not a big issue for sharing. And this morning we can see there is a very good tool for this sharing that we may use for the future. And for that, I think the security, the server security also can be some issue. I think during this analysis also, the big challenge coming that we are working with Excel. I think we keep working with Excel, and this Excel also sometimes for when we extract data, or there is some format which may lead for some of those errors that we face during the analysis. And if there is another many tools that we show which may be more suitable than Excel, that can prevent site to have those kind of error, and which can have very great impact on the data quality during your analysis. And from there, I can stop here. In if there is any question, I can go through from our side. This is our experience in, for data quality in Mali. Thank you.
Thank you, Dr. Saro, for that presentation where you capture some of the challenge that you faced, such as the challenge with the data capturing, issue with storage, as well as the sharing issue, which has some problem as a result of some connectivity issue. So maybe we take all the presentation and then we can go back to question and answer. So if you have any question, kindly put it on the chat. And then we can have a panel discussion at the end of the presentation. So the second presentation is from Uganda. Do we have any representative from Uganda? Yes, so if none, can we have a representative from Zambia to share their challenge with data upload, storage, and using trusted research environment?
Hi, Upendo. I don't believe we have anyone from Zambia, but I will try and give a Zim overview.
Thank you, Takis. Welcome.
Thank you. So I really just have one slide really. So good afternoon, everyone. My name is Tabutswa Mtisi, and for those that may not be in the know, I have been with the ZIM group. I'll explain in a little bit since the inception of implementation of what we term the SHA study, which is Sickle hemoglobinopathy research in ZIM and Zambia. Our acronym is 1Z, but we are technically 2 countries. So my talk today, or my discussion today, is really going to highlight our unique experience as one site, one NIH site, but what is in practice really 2 different countries. So I was asked to highlight how we've managed our data workflows across the 2 countries, how we have harmonized data structures, and how we have overcome, or rather say how we keep trying to overcome cross-border challenges. So just to give a brief background, again, for the benefit of, there's some new names that I see in the meeting. So I wouldn't want to take it for granted. So what has happened is when the grant application was made, it was made with Zimbabwe and Zambia coming in one application. But in terms of implementation, we are really 2 countries, Zimbabwe and Zambia. The PI is Zimbabwean and resident in Zimbabwe, and then we have 2 co-PIs, one from ZIM and one from Zambia. In Zimbabwe, we have 5, I've called them sub-sites here. And in Zambia, there was only 1 site, and this is because of our numbers. ZIM is much lower on the map, more southerly, and there's much less sickle cell disease as compared to those countries as we move up towards the equator. So geographically, Zimbabwe SHAS sites consist of 5 hospitals, which are in 3 different provinces. So as you can imagine, this would pose logistical challenges, which have not spared us from even the data challenges. We, however, because we are one site, we actually just use one REDCap database. So from the get-go, we had to have a unique situation where we are more than one site, which again may not be as unique if we were coming in from just one country. If it was just ZIM with its 5 sites, but we have 2 different countries that are involved. The easiest way to do this, Mario will testify that when we started, I used to bother him a lot. I'm not primarily a data person, but when we started the study, I was responsible both for the operations and even the data management. We didn't have a dedicated data manager or database manager. So we had to navigate our way and see how best to do this without compromising on data. We didn't want for it not to be as obvious when you get into the database, which data is coming from which country, or at least from which site. Eventually, we decided that the Zim data, because of our numbers, could all appear in one data access group. And then we could always select by hospital if we want to do any sort of mini analysis. But we separated the data using data access groups, and then we have multi-level rights. So for example, data capturers from Zim and Zambia cannot, see or access each other's data, but the PIs, the database manager, myself, we are able to access both. So if we need to raise any queries, we can do that from either side. Again, the structure in terms of the organogram on the ground, the coordinator was residing here together with the PI, but we needed someone on the ground still in Zambia. So in Zambia, we have a research assistant who operates somewhat as the immediate supervisor for the data capturers there. And then in Zim, we've got, we now have a database manager. And I believe Xavier is on the call. He's the one who has taken on that role. Because we are two different countries, that means we have two different legislative frameworks. That means a lot of things for the lawyers. But for us, what it meant was we couldn't have a blanket approach to handling our data. What's acceptable in Zim is not necessarily what's acceptable in Zambia. These had particular implications on data sharing. So I'll give 2 examples. I've given 2 examples here. We have not been able to grant the DCC direct access to RedCap via the API because we were not authorized to do so. So when we put in our regulatory applications at the beginning, the lesson learned is we needed to have been very clear what we're asking for, because that's what they go by. So the data sharing agreement that was later developed speaks of particular data elements, just a few, I think, don't remember if it's appendix 1 or 2. So those are the only data points we've been able to share with the DCC. So this has implications because I'm sure there's some consortium level analysis that may need to happen for which we are not able to share data, at least not using the current regulatory approvals. We would need to go through amendments and lots of paperwork. So currently, I think we share very minimal basic demographics with the DCC, and we do this manually. Upendo has designed, I know it pops up in my calendar every month, I believe, to update these numbers. Or between Mario and ourselves, we are sending, just the numbers over email, as opposed to Mario himself or Wilson or Martha or somebody from DCC being able to just get into our RedCap and access this data. So those are some of the implications of the regulatory frameworks or the environments in which we are operating. Zambia has similar strict data sharing rules. We were also not able to do that. It has also resulted in us not being able to share all our data at the same time. Mario and Xavier are in a constant, communication, updating each other on where are we with this data sharing agreement, what can we upload from Zim, what can we upload from Zambia, depending on the stage at which we are at. By the time we did the NBS study, we were a bit more knowledgeable. So when we applied for NBS, we tried to make sure that we put in the application that will be sharing essentially all the data that we're collecting as part of the consortium. By that time, I believe we also had a consortium agreement in place. So we were able to at least share our data with the DCC, which is what the agreement says. And then much like Mario has labored to discuss here, they don't share data from the different sites without prior permission from the PIs and all that. So we are able to share data from the NBS almost in its entirety with the DCC, with the understanding that that data is not accessible or to other sites directly. It's essentially, quote unquote, controlled by the DCC, and any requests for access to it would need to go through the PI, who, if she needs to, would be consulting with our regulators here, and then permission can then be granted. So you'll find things have not been very easy for Mario, for Vicky, with the Zim site because of challenges in trying to navigate this. Sometimes you almost feel like, oh, I hope people think we're not just being too difficult, but our legislative environments do not allow us to make some of these decisions without following due protocol. We have also had some staff challenges at different levels. Like I indicated, Zim has 5 sites in 3 different provinces, which are a good maybe 300-400 kilometers apart. She's mainly based in Harare, which is more like a central location. But what that has meant for us in terms of implementing all our studies is that we have to periodically go out to the sites to collect data. Unlike other sites, which I believe, our colleagues have got staff at the various clinics, the various hospitals, who play somewhat of a dual role, or at least there is research staff there who can easily navigate in a hospital and follow up any patients that are coming. So we have not been able to do that. We have functioned using more like an outreach system until quite recently, when we had a few more numbers coming out of Motoko, which is 140 kilometers from Harare. And also the site we undertook the NBA study, and we'll be doing the malaria study. So now there's a dedicated research assistant there / data capturer who's also undertaking SHA's roles in terms of capturing data, particularly follow-up, because we were missing some patients who may turn up for a clinic visit within the period which we could see them for follow-up and collect their follow-up data. So we've tried to address that way. And then for Zambia, Zambia had a different model. They didn't have like permanent staff who were collecting data. The Zambia model was mostly medical personnel, medical doctors, physicians, pediatricians, and some nurses who were actually working in the sickle cell disease clinics. And then they would then collect this data, enroll these participants, consent them, enroll them, follow them up as was appropriate. And some of the staff, particularly the medical doctors, would have been maybe pediatricians in training or physicians in training. So once they are done with their training, when they graduate with their MMed, they have been posted outside Lusaka, leaving the gap. So we've had quite a bit of staff turnover in Zambia, but they've still continued to use the same model. They train the new doctors who are imposed at the time, and then they are the ones who collect data. We've also, we had Cynthia, who had started with the Zambia group as their research assistant, providing that first level oversight of, or rather the coordination of the Zambia data, who has since moved on to something else. I believe she's in school right now. So again, even she has been replaced by a new person. So you appreciate how we have needed to continually train and retrain. Initially, when we started, we would have weekly data meetings. They became every fortnight. And then now, as things have more or less stabilized, we have monthly meetings, all in a bit to try and harmonize how we are collecting our data. And because we have this one database manager, or at the time when I was carrying out these duties, we needed to coordinate with each other, including with the Zambia team, whenever they wanted to sync data, which speaks to the last challenge that I put there, of internet, because we are working in these rural sites mostly, and even the two urban ones, the Pari, which is our main site in Zim, and UTH, the site in Zambia. They are very well within the capital cities, but the hospitals themselves don't quite have, good internet. So we rely on collecting data using the offline app. And then once we have good internet connectivity, once we get back into the office, then we can sync the data. And we've had some challenges where, I don't know the technical terms of it, but the data doesn't sync properly. Some of it sort of gets suspended or lost in the cloud, and then we needed to be engaging the Marios of this world to help us try and locate this data. So those are some of the challenges I thought we could highlight. Is a unique site from Zim and Zam, but I'm happy that we are now getting into the final year of SHARS and have, while some of them are not really permanent solutions, we've managed to navigate our way and as much as possible try to participate in the Sparkle or Sickle in Africa activities as required. I think I will stop there, and I will also welcome any comments or questions at the time when they are called for. Thank you. Over to you, Opiendo.
Thank you, Takuza, for such a presentation. Definitely a unique site. And from the presentation and from what I've captured, she highlighted some of the challenges that were also mentioned with Ruben regarding the staff turnover and multiple retraining, as well as regulatory challenges that lead to difficulty in sharing data with DCC. So do we have a representative from Uganda before we go to the Q&A session? So the floor is open. If you have any question, please unmute and ask. Maybe I can start with Dr. Sarah. I think you reported the challenges with the use of Excel. So if I got it right, you do collect data from Excel and import into a red cap. Is that for the registry or for the research studies?
Thank you. If I understand well, the Excel is just the export from RedCap that we share with our analyzing team, like Wilson, and there was some of those problems coming from this the management of this Excel from after his exportation to the submission to the to Wilson for analysis. But our problem is I think yesterday Mario pointed out that the team, the South African team cannot access our RedCap directly. It's a standalone and there is a firewall, and we we discussed a lot with the provider to change this setup, but it seemed that he don't like to change this setup. This is why I think yesterday I like Mario proposal to see if we can have another red cap from South Africa, and we don't have this firewall, and that the team from South Africa or from the DCC can get directly and export data, analyze them. But right now we are exporting them here and try to submit to South Africa for analysis. I think this export and sending, sharing part may create some problem or no some data, and this is just an hypothesis that we found during our data cleaning session, and that some of those inconsistency may coming from Excel management during their export. Yeah, we are not entering data in Excel, but it just the format for extracting and submit to the analysis team.
Okay, thank you, Dr. Sarah. Also from the presentation, I think I've heard so much about the technology and data sharing, but if I've heard from the team on the experience with the trusted research environment, Takuza or Dr. Sarah.
Please come
I
again.
did.
Then.
Okay, go ahead. Go ahead.
So I was saying I've had experience with the data storage and data sharing, but we'll be happy also to hear on your experience with the trusted research environment, the TRE.
Okay, for that one, I will invite Xavier to respond because I know he's been directly communicating with Mario. My role is just to make sure that whatever we're sharing is we are compliant with our regulators. So I know we've used some of these Next clouds and all the platforms that Mario alluded to, and I invite Xavier to share the experience for Zimzam. Xavier, if you can hear me. Or if he can't, maybe Mario can update us on what challenges you've experienced with the Zimzam team. I can tell you that most of it lie within data sharing. What elements are we able to share with the team? And at which point we've not been able to share our data at the same time, which is the stepwise approach that I've alluded to. Xavier, if you can hear me, please respond, or if not, I invite Mario. Thank you.
I think Mario did step away a little bit. Maybe Sarah, you can go ahead while we wait for Mario and Xavier.
Okay. This is my first time to see this tool, but by the team, but our data management team, so one is connected. Moussa, est-ce que vous avez l'habitude d'utiliser l'outil ici qu'on a montré, le Trusted Research Environment là? Okay, this is my first time to be in face of these tools, and I'm sure maybe the data management team know it already, but I don't know if because they are sharing data usually with the help of Wilson and everything. I don't know if Wilson data sharing method include this one or not. If it include this, that means the team is already using that already. But for me, myself, I just see this tool today, but this is not a problem because I'm not fully involved in the data management in the team. But the team who is connected, maybe he's not following. I can get the answer and share it after. Thank you.
No problem, no problem, Dr. Sarah. Thank you. But I can also see online we have Evans and Ruben. I think yesterday you were able to share some of the challenges that are quality. But maybe we can also hear from you, your experience with data storage, sharing and the TRE. Maybe you can share just briefly a comment on this. Hello, Ruben and Evans.
Yeah, can you hear me? Good afternoon, everyone.
We can hear you.
Yes, so we have a university policy on data storage, and we also do share when, with the hub, SADC, when the request has been approved, we share that. So, but on our cloud, we have a proper storage policy. So currently, I'm not very. I don't have it hands-on where the backup is done, but we have a server that was shared from SADC. We also have our backup storage in the university. I think that's the comment I have for now. Thank you.
Thank you, Ruben. Evans? Okay, I can see it online. So do we have any question from member to the from the presentation shared by the Zambian, Zimbabwe team and the Mali team?
Can you repeat the question?
No, I just asked the members if they have any question to Mali and Zim and Zimbabwe team.
Oh, okay. I think the team is not we will really go in deep for them to use this trusted research environment. But for now, I'm not sure if they are using it. But they usually transfer the data from a link that Wilson or Mario just provide to them. That's the way we are sharing data now.
Thank you, Dr. Sarah. So do you have any other burning question or comment? So if none, thank you for all presenters for sharing some of the challenge that you encountered with the data storage, data sharing, and your experience with a trusted research environment. Back to you, Martha. Thank you.
Thank you, Upendo, for that. Thank you for chairing the session. Thank you again to everybody for attending today's session, and I hope we learned quite a few things today from data sharing in the trusted research environment. It's quite an interesting environment, although we do need to be aware of the privacy and security issues associated with that environment and how we can navigate those data sharing regulations, as was highlighted by some of the panelists, and how we can navigate those or work together or collaborate in that environment. It's a very interesting environment because we are also able to run our code in there, run analysis in that environment. Ideally, in an ideal world, we'd like to just have one place where we can do everything in one go. But as we've noticed or we've heard from the speakers, there are many challenges to doing this. So for tomorrow, we would continue with the same discussions again, but this time tomorrow we'll be looking at we'll have some speakers again tomorrow that will highlight how our communities can come together and share data. We will also have a presentation from Wilson, who will talk about some of the data quality issues that we actually see in the registry. And towards the end of that presentation, we'll have a discussion from Prof. Andre, who will give us a map or a direction into how we can start analyzing some of the data that we have from the registry under phase 2. Again, I want to thank the speakers and everybody who participated in today's session, and we hope to see you tomorrow.
Thank you, Martha.
Thank you, everyone. Good day, everyone.
Thank you.